Welcome everyone to the Unit 3 study guide review video. We are solving equations and solving simultaneous linear equations. As always, if you can do every question on this study guide independently, then I have no doubt that you'll earn an A on the test on Wednesday this week. So we have a circle. For question 1, a circle has a mass of 4 grams and a square has a mass of 3 grams. What is the mass of a triangle? Mass is a word that means weight, basically, but there's no gravity involved. So we have the mass of a circle is 4, 4, 4, 4, 4. The mass of the square, 3, 3, 3, 3. And we're trying to figure out the mass of the triangle. Okay, so what I would do off the bat here is I would see, okay, is there anything I can get rid of right away? Yeah, this circle on this side of the equation, if I remove that, my hanger isn't balanced yet, but then if I remove this, my hanger is back to being balanced again. So I can subtract 4 or take away 1 triangle from both sides, or circle from both sides. And then I can keep doing that. Anything that's on both sides of this hanger diagram is like anything that's on both sides of the equation. I can remove it, take it away, as long as I do it to both sides. So here's another circle, here's another circle, here's a square, here's another square. So I've taken away all my circles and my squares that are on both sides of the equation. I also have triangles on both sides. So I have one triangle here, remove it, one triangle here, remove it. And after I've done that, I'm left with just 2 triangles on the left-hand side. And on the right-hand side, I have a circle that's 4 grams, a square that's 3 grams, and a second square that's 3 grams. So that means that my 2 triangles have to equal 4 plus 3 grams, which is 10. So if 2 triangles are 10 grams, I can divide both sides by 2 and figure out that one triangle, or a triangle, is 5 grams. Okay, so key ideas to this problem is remembering for these hanger models, if you have something on both sides of the equal sign, you can remove it. And then once we've taken all the shapes that are on both sides away, we see what's left, and we should have a pretty basic equation then to solve. You could also write an equation with everything before removing circles and squares and triangles from both sides, and you could definitely do that. It would just be a longer equation. So I would do it this way, but up to you. All right, moving along to question number 2. Helena solved the equation below incorrectly. Identify and explain Helena's error. So right off the bat, I see I have parentheses, and I have variables on both sides and parentheses on both sides of the equation. We should know right off the bat, okay, when I have parentheses, I have to apply the distributive property. So on this side of my equation, I have 5 times 1/5 x and 5 times the minus 5. So I need to distribute here using the distributive property. Okay, and then what I would do is I would actually do it. Like if I do that, 5 times 1/5 x minus 5, what should I get? Well, I do 5 times 1/5, that's equal to 1 x. And then 5 times minus 5 is going to be minus 25. Okay, that's what Helena got on the left-hand side, so we're good there. On the right-hand side, I also have parentheses, and I'm also going to apply the distributive property. So I have negative 2 times 2x, that's equal to negative 4x. Then I have negative 2 times 4, that would be equal to plus negative 8x, or minus 8. Or sorry, not x. Plus negative 8, or minus 8. Okay, so then let's see, is that what Helena had? No, Helena had plus 4 here. So Helena distributed the negative 2 to the 2x to get this, but forgot to distribute the negative 2 to the 4. A very common mistake. Okay, so that's her error. So then I can just write a nice sentence, right? Helena did not distribute or multiply the negative 2 coefficient. That's a really good word. I wouldn't require you to use it on the test, but that's the term for the word in front of the any algebraic expression that's getting multiplied, the coefficient of -2 by the 4. Okay, and again, I have the picture here. I have what it should be here. So that's really enough to have it, right? This should have been this. It's clear that the mistake is around the distributive property, and I see what it should have been versus what it is. All right, cool. Moving on to question 3. Question 3 says, determine whether each equation has no solution, one solution, or infinitely many solutions. Select the correct cell in each row and show your thinking. So we're going to start with this equation. We have 16x minus 12. These are not like terms, so I can't combine them or do anything to them. And then on the right-hand side, I have, again, parentheses. So whenever I have parentheses, I want to think, okay, I need to distribute. So I'm going to distribute the 8 to the 2x and the 8 to the minus 2. 8 times 2x is 16x, and 8 times minus 2 is going to be minus 16. And then I have a plus 4. Okay, so at this point I notice, I have 16x and 16x. When I have the same variable term on both sides, that's going to indicate for me that we're going to have either no solutions or infinitely many solutions. Then we have to look at what's happening for these constant terms. So again, now we can simplify and combine like terms. We have this negative 16 plus 4, or minus 16 plus 4. We got to be really careful here. If we have a minus 16, we have to see that as adding a negative 16. We have to see that 16 is negative. So negative 16 plus 4 is negative 12. So we'd have like plus negative 12. Or this is equivalent to 16x minus 12 equals 16x minus 12. At that stage, we should look at this and say, these are the exact same thing, the exact same expression on both sides of the equation. And when we have the exact same equivalent expressions on both sides of the equal sign, we're going to have infinitely many solutions. Any value for x is going to make this true, because no matter what x is, we get the exact same thing on both sides of the equal sign. So it's always going to be true. Okay, so we always have infinitely many solutions when we have equivalent expressions on both sides of the equal sign. You wouldn't need to write this equivalent expressions. I'm just writing it there as an example, how I can identify that. Okay, then I can go on to the next equation. I have negative 7x equals negative 7x plus 5. So right off the bat here, I should recognize that again I have the same variable terms, but this time I have a plus 5 on the right, a constant term of 5 on the right, and I have no constant term on the left. So I could get that it's no solution from there, but we can just go an extra step to see why. Let's say I want to get rid of the fact that I have this negative 7x on both sides. So how do I get rid of a negative 7x? I'm going to add 7x to both sides. Okay, negative 7 plus 7 is equal to 0. So if I add 7x on both sides, here I have negative 7x plus 7x equals 0. And here I have negative 7x plus 7x is 0 plus 5. So we get 0 equals 5. In order for this equation to have a solution, 0 has to be equal to 5, which is false. That is not true. So this has no solutions. Okay, and then finally, for the last one, we have parentheses on the left. So let's try to simplify there. 2 times 3x is 6x. 2 times minus 1 is minus 2. So we get 6x minus 2 equals 5x minus 2. At this point, I see that I have different variable terms. And when I have different variable terms, I'm going to be able to solve this equation and get one solution. So one solution because I have different variable terms. And I could keep solving it, and oh look, they want me to in question B. So in question B it says one of the above equations has one solution. Solve that equation for x. So I'm going to rewrite this equation that I know has one solution, and I'm going to find it. We're going to distribute like I just did above. Okay, and now I can do anything I want, get rid of anything I want to, try to simplify the equation, get x all by itself. So I can pick something I want to get rid of. People often will try to get rid of a -2 here, which I will do, but I do think it looks a little confusing after, so we'll talk through that. So we want to get rid of a -2. We get rid of a -2 by adding 2. So I add 2 to both sides. -2 or -2 plus 2, this all goes away to 0, and I get 5x equals 6x.
How you doing?
Good, how are you?
Yeah.
Okay, so at this point I get 6x equals... At this point, I get 6x is equal to 5x. So that often messes people up, which I understand, but we ultimately now have variable terms on both sides, and we want to only have variables on one side. So I can pick one of these variable terms to try to get rid of. So I have 5x. Let me try to get rid of 5x. So I'll rewrite it just for some space here. If I have 5x and I want to get rid of 5x, I can subtract 5x from both sides. Okay, when I do that, 5x minus 5x is equal to 0, and 6x minus 5x is equal to 1x. So I get 1x equals 0, or x equals 0. So this has one solution. In order for this equation to be true, x needs to be 0, and I'll get 0 equals 0, or here -2 equals -2. Okay, so a little tricky. Again, people get confused with the 6x equals 5x, but if you have different variable terms on both sides of the equation, you always just want to try to get rid of one of the variable terms so that you can get x all by itself. You could have subtracted 5x from both sides first here, which might have made it a little easier to see. Okay, awesome. Now we're moving into systems. So question 4 is when we switch over to the systems or simultaneous linear equations. This problem is about doing it by graphing. A line is graphed on the coordinate plane to the left. Graph the line y equals -1x plus 6 on the same coordinate plane to create a system of equations. What is the solution to that system? So I have one line graphed, and they're telling me now I need to graph a second line. Y equals -1x plus 6. So in order to graph a line that's in slope-intercept form, y equals mx plus b, I need to identify m, the slope, and b, the y-intercept. Okay, the y-intercept here is 6, and the slope here is -1. Okay, if my y-intercept is 6, that means I have the point 0, 6, that my line crosses the y-axis at 0, 6, so I can put a point there. Okay, then I can do the same sort of idea. I need to interpret my slope. Okay, so my slope is -1. And slope is really only helpful for us when we're graphing if we can understand it as a fraction. So I want to write the slope -1 as a fraction, -1 over 1. Any number divided by 1 is itself. So if I have a whole number slope like -1 or 2 or 8, I can always stick it under 1 to interpret it as a vertical change divided by a horizontal change. If I'm going vertically -1, that means I'm going down 1. And if I'm going horizontally +1, it means I'm going right 1, because vertical means up and down, and in this case it's negative, and horizontal means left and right. So I use that to say, okay, let me start here again at my y-intercept, go down 1, right 1, down 1, right 1. And there we are. I have graphed a second line, and I see they intersect somewhere. Where do they intersect? They intersect at this point, 2, 4. So that's my answer. That's my solution to the system, 2, 4. Okay, you want to make sure, even after you graph it, that you have boxed in that answer. That's the final answer, the ordered pair. Okay. Moving on to question 5. Here's the graph for one of the equations in a system of 2 linear equations. Again, we have one of the 2 lines graphed. We're told that the solution to the system is -3, -4. Select the equation that could be the other equation in the system. Explain how you know and show your work to receive credit. So I have the point -3, -4. We're saying this is the solution. So that means that the second line in the system must go through that point. It must intersect here. Okay, so there are 2 ways to do this problem. You can do it by graphing, or you can do it by checking the solutions algebraically. So I'm going to do it by graphing first, and then I'll do it algebraically. On the test, you just choose whichever method you want to do and do it. So let's just go answer by answer. Here, y equals 1x plus -1. I'm going to try to graph that. So this has a y-intercept of -1, and we're saying we have a slope of 1. So a slope of 1 means I'm going up 1, right 1. Up 1, right 1, up 1, right 1, up 1, right 1. Okay, but what's going to be significant here, because remember this is forming a line that goes infinitely in both directions, is the slope of 1 also means you can go down 1, left 1. Because -1 divided by 1 is also 1. So we can keep the pattern. And when I do this, we see, oh, that works. Okay, if I graph this line, it's going to intersect the other line at the point -3, -4. So that's the solution. That's one way of getting it algebraically. I'm going to very briefly check the other 2 to show that they don't work. So for B, I have a y-intercept of 3. I have a slope of -3/4, so I would go down 3, right 4. Okay, that's going to cross the other line around here, which is not -3/4, so that can't be it. And this one has a y-intercept of -2 and a slope of 4, which would look like this line, and it would intersect at 0, -2, right? Not at -3, -4. So neither of those have a solution, or neither of them would intersect the line we currently have graphed at -3, -4, so that can't be the second line, because we need the solution to be -3, -4. Okay, we can also do this algebraically. So if we have y equals 1x plus -1, and -3, -4 is the solution, that means when we substitute in x for -3 and y for -4, we should get a true equation. It should be a solution algebraically to this. So y is -4 here. X is -3. I'm substituting those in. And I get -4 on the left-hand side equals -3 plus -1. And -4 does equal -4 here, -3 plus -1. So that is a solution to the equation. If I tried with the other 2 equations, I'm not going to get a true equation. If y is -4, x is -3, this will be 9/4 plus 3. -4 doesn't equal positive 9/4 plus 3. This is going to be a positive number. This is going to be a negative number. So those aren't equal, so that's not a solution. And then y equals 4x minus 2. Y is -4. X is -3. negative 4 equals negative 12 minus 2. That is not true. You get negative 4 equals negative 14. Again, not true, so that can't be the solution as well. So we could graph all three lines and make sure we choose the one where it intersects at negative 3, negative 4, or we could algebraically check that that point is a solution to that equation. Again, you don't need to do both. You do need to do one of them and clearly show your work and explain what you did. Okay. Moving on to 6. Jordan and Bryce are going to work for their neighbor this summer. The neighbor gives Jordan $10 at the beginning of the summer and then pays them $8 each week to mow the lawn. The neighbor pays Bryce $9 each week to walk the dog. The graph shown below models the total amount of money Y each person has earned after working for X weeks. Circle the option that represents the point of intersection on the graph. Okay, to be very clear here, this is definitely the easiest question on the test. It's a straightforward, simple, multiple choice question, just making sure you understand what a point is on the graph and what a solution of a system means. We should all get the question that's very similar to this on the test right. Speaking of the question that's actually on the test, like I often do on these study guides, forgot to change the names here, because on the actual test, we will have Noah and Aiden instead of Jordan and Bryce, and I just forgot to change that. So again, you'll see a question super similar to this with the names Noah and Aiden instead of Jordan or Bryce. Okay, so circle the option below that represents the point of intersection on the graph. So I should figure out where the lines intersect. Okay, they intersect right here. That's where they're crossing. And what is this point? 1090. So I have the point 1090. What does the point 1090 mean? Well, when I look at 10, I'm on the x-axis. The x-axis here is talking about the number of weeks. So that 10 means 10 weeks. And this 90 is my y-coordinate. It's talking about the amount of money. So after 10 weeks, it's $90. Okay, and then we have a graph for Jordan and a graph for Bryce. This is the point where they intersect. This is the solution to the simultaneous linear equations. They simultaneously, at the same time, have the same amount of money. A solution to a system is when they have the same amount. So after 10 weeks, each person has earned a total of $90. The 90 weeks, off the bat, that's wrong. We're not talking about 90 weeks. We're talking about $90. And then for A, it's not, they don't have different amounts of money after 10 weeks. After 10 weeks, they have the same amount of money. Okay, all that is a multiple choice question. Okay, moving along. Now we have question 7. A long question, but very doable. Here we have another example of a simultaneous linear equation. We have Hector and Michelle. Hector and Michelle are each saving money. Hector starts with $50 in his savings account and then adds $10 per week. Michelle starts with $20 in her savings account and adds $20 each week. Complete the table to determine after how many weeks they have the same amount of money. So here is Hector. At week 0, Hector still has $50 in his savings account because that's what he starts out with. So week 0, Hector has $50. And he adds $10 per week. So after 1 week, he now has $60. After 2 weeks, he has $70. After 3 weeks, he has $80, 4 weeks, $90, 5 weeks, $100. We're adding $10 for each week. This table is nice, we're just counting by ones here, so we're adding a constant amount each time. Now we have Michelle. Michelle starts with $20 in her savings account, and then she adds $20 each week. So 1 week goes by, $20 more goes into her account. Another week goes by, another $20. Another week, another $20. Another week, another $20. So then we consider this question. After how many weeks do they have the same amount of money? So is there a week where they both have the same amount of money? So I look at both my tables, and yeah, there is. After 3 weeks, they both have $80. So that's the solution to the system, 3 weeks, $80. I already know the answer from the table. However, I'm making you not just find it from the table, I'm also making you write simultaneous linear equations that represent this, and then solve it algebraically. So the table is important, and we should know at this point what the correct answer is, but now we got to figure it out other ways as well. So now we're going to write 2 simultaneous linear equations to represent how much money Hector and Michelle have, y, based on how many weeks they have worked, or have passed. Okay, so we're going to write an equation for Hector and an equation for Michelle. Hector has y money, how much money he has y, is based on how many weeks have passed, x. So how much money does Hector start with? He starts with $50. That is his y-intercept, or his starting amount. And then he gets $10 each week. $10 times the number of weeks that are passed. So 10 is like my slope here. It's my constant rate of change. I'm adding $10 each week. And 50 is my y-intercept, my starting amount. Okay, same thing for Michelle. Michelle starts with $20 in her account and gets $20 each week. So her equation is y equals 20x plus 20. So again here, my y-intercept, that's like my starting amount at week 0. And my slope is my weekly rate, how much more money I get each week. And now we're told to solve the system we just wrote algebraically using substitution to determine after how many weeks they have the same amount of money. So we want to figure out, when are they the same? What is the solution? Again, we already know they're the same at 3 weeks, but that's not really the point. The point is, can we show that algebraically? So to solve this system with algebra, we know, okay, we can always expect y to equal y. We need Hector's amount of money to equal Michelle's amount of money. Hector's amount of money is 10x plus 50. Michelle's amount of money is 20x plus 20. We need them to be equal, so we set those equal to each other and we solve the equation. Variables on both sides, I'll choose this 10x to try to get rid of. How do I get rid of a 10x? I subtract 10x from both sides, rewrite the equation, leaving myself some space. Minus 10x minus 10x. 10x minus 10x is 0, so that goes away. 50 equals 10x plus 20. Okay, I'm good now. I only have x's on the right-hand side, but I want to keep solving this. I need to get x by itself. I have this plus 20, so let's try to get rid of the plus 20. How do I get rid of a plus 20? I subtract 20 from both sides. When I do that, 50 minus 20 is 30. 10x plus 20 minus 20 is 0, so we just get 10x. And then 10x is equal to 30, so I divide both sides by 10, and x equals 3. Oh look, that's what I thought I was supposed to get. So that's saying x weeks is 3. That's not quite the solution though. I also need to find how much money they have after 3 weeks. Again, we already know it's in the table, it's $80, but we're going to show it algebraically using substitution. So we can take one of these equations, y equals 10x plus 50, and I can substitute in 3 for x, since I now know x is 3. 10 times 3 is 30. 30 plus 50 is 80. So the solution is 3, 80, which means after 3 weeks, they both have $80 saved. Okay, that would be like the point on the graph, and this is the real world meaning. So I'm going to make this clear just so we don't have issues on the test. You need to do this algebraically to get full credit, even if you get the answer from the table. That's good, and I'm proud of that, but I need to see that you can solve it using the algebra too. Okay, and finally, which system of linear equations has no solution? Show or explain your thinking. So for a system to have no solutions, that means I have to have parallel lines, because that means they never intersect. And how do I get parallel lines? That means I need to have the same slope and different y-intercepts. Okay, so a quick look at these equations and I can see, hey, D fits that requirement. I have the same slope of -3, and I have different y-intercepts of 7 and 10. So those are going to be parallel lines. Now that's how I would do this question. However, if you want to solve this algebraically, you're welcome to. You can set 5x plus 6 and 8x plus 2 equal to each other, and you'll get one solution to this equation. This will have one solution. You can use substitution here. A little bit of work, but you can use substitution, or you can see that this is like double the first one, and you will get that this has infinite solutions. Those are equivalent equations. Here, we can substitute in 8 for y here and get one solution. But again, D, we could set those equal to each other and we would get a false equation. We would get 7 equals 10 if we tried to solve that. So again, we'd have no solutions. Woo! Okay, that's it. Go get an A. Ask me if you need any help. Watch this video as much as you need. Search for some other videos if you need. Do practice problems. Watching this video is not enough. You need to be able to do the problems yourself. Use this video to help you check your work, to get clarification if you're confused, but watching this, just watching it is not enough to study. You have to do the problems. Doing math is how you learn math. All right, good luck, everyone. Thanks for watching.